Day 792 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2492, minimum score of a path between two cities. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given a positive integer n representing n cities numbered from 1 to n. You are also given a 2D array roads where roads of I is equal to AI, BI, distance I indicates that there's a bidirectional road between cities AI and BI with a distance equal to distance I. The city's graph is not necessarily connected. The score of a path between two cities is defined as the minimum distance of a road in this path. Return the minimum possible score of a path between cities 1 and n. Note, a path is a sequence of roads between two cities. It is allowed for a path to contain the same road multiple times, and you can visit cities 1 and n multiple times along the path. The test cases are generated such that there is at least one path between 1 and n. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input n equals 4, roads equals a 2D array of integers. First array 1, 2, 9, next array 2, 3, 6, third array 2, 4, and 5, and the last array 1, 4, and 7. The output is 5. The explanation says the path from city 1 to 4 with the minimum score is 1 to 2 to 4. The score of this has a minimum of 9. We choose the minimum between 9 and 5, so that would be 5. It says it can be shown that no other path has less than this score. All right, y'all, so let's break this down one step further, right? So let's go through what this input actually means. So n equals 4, right? So first thing that lets us know is we want to go from 1 to n. So we want to go from 1 to 4, right? But we want the minimum path. So then we have this 2D array of roads. So it AI, BI, and distance I, right, up here. So this would be AI, this would be BI, and this would be distance I. And same with every array. This would be AI, this would be BI, this would be distance I. Same here. This AI, BI, distance I, and same here for all of them, right? So boom. So we go. This lets us know we have a path from 1 to 2, and it has a distance of 9, right? So that's where this 9 comes from on this path of 1 to 2. Then this right here lets us know we have a path from 2 to 3 with a distance of 6. Boom. So that's why this 2 to 3 right here has a distance of 6. From 2 to 4, the path from 2 to 4, right here to right here, has a distance of 5, right? That's what this distance I right here. And same with the path from 1 to 4 has a distance of 7 right here. Now we want to find the path with the smallest distance, or the minimum possible score, excuse me. And the score is calculated by the minimum distance of a road in this path, right? So right here we went from 1, we want to get to 4 because n equals 4. So we go from 1 to 2, and then we go from 2 to 4. That has then we take the minimum of 9 and 5, and since 5 is smaller than 9, we choose 5, and that's why output is 5, right? Boom, that's what this is right here, because we went from 1 to 2 to 2 to 4. Boom, so we got the 9. That's where this 9 came from, and that's where this 5 came from, and we picked the minimum, whichever is smaller. Now, you might think we could just go from 1 straight to 4, but if we went from 1 to 4, if we went straight there, that would have a distance of 7, and that's not the minimum score, right? 5 is smaller than 7, so we want the smallest score, so that's why this path is more optimal. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, our input n equals 4, rows equals a 2D array of integers. First array is 1, 2, 2, then the next array is 1, 3, 4, and then the last array is 3, 4, 7. This time the output is 2. It says the path from city 1 to 4 with the minimum score is 1 to 2 to 1 to 3 to 4. The score of this path is a minimum of 2, 2, 4, and 7, which is 2. So in this case, similarly, just like we didn't want to go straight from 1 to 4 up here, same thing down here. We want to get to 4, but if we went to 1 to 3 to 4, that would have a minimum score of just 4, right? Because the minimum, then we would just need the minimum between 7 and 4. But it says right here, it is allowed that for a path to contain the same road multiple times, and you can visit city 1 and N multiple times along the path. So in this case, we're going to go to 1 to 2, so we could pick up this 2 right here, and that's going to change our score. We're going to come get this minimum score by going from 1 to 2. Then we're going to go from 2 back to 1. Boom. That's what this is right here. And then from 1, we go to 3 and 4. And then in the end, we get the minimum of this because we went to pick this 2 up right here. Then we picked it up when we went back. And the minimum of this would be 2. So that's why the output is 2, y'all. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we need to do is we're going to build an adjacency list with the variable. So we're going to declare a variable called graph, say colon, open up this square brackets, open up the parentheses. It's going to be an array of tuples, and we're going to say int, comma, int, boom. Then we'll come outside and initialize it with a blank dictionary like this. Boom. Now we're going to come underneath this, and we're going to say for road n roads. We're going to open up the brackets, and since the roads are bidirectional and an edge, we're going to add an edge in both directions. So we're going to say graph, square bracket road, square bracket 0, come outside of that, comma, default, colon, put a blank array, come outside of that, and we're going to say dot append, open up the parentheses, we're going to say road, square bracket 1, come outside of that, comma, road, square bracket 2. Boom. And sorry, these 2 roads need to be in parentheses, so like this. Boom. Then we can copy and paste this, copy and paste that, bring it underneath this, but we're going to change this road to a 1. We're going to change this right here to a 0, and then that's it. Now we need to track the smallest road distance encountered while exploring the connected component containing city 1. So first we need to create another variable. We'll call it min dist, and we'll set that equal to int.max. Boom. Now we're going to keep track of which cities have already been visited during the we're going to create a DFS function or depth first search function to avoid revisiting them. So we haven't created the helper function yet, but we're going to create the variable now for the visited variable. So we're going to declare a variable, call it visited, and we'll set that equal to an array. We'll open up the parentheses and we'll say repeating colon false comma default comma count colon n plus n. Boom. Now we're going to create our depth first search function by coming right here underneath that variable, still inside the main function, and we're going to say func dfs, open up the parentheses, underscore node colon, that's going to be an integer, come outside of that, open up the parentheses, and we're going to mark the current city as visited, so we're going to say visited square bracket node, set that equal to true. Boom. Then we'll come underneath that and we're going to explore all neighboring cities and roads. So we'll say for edge in graph square bracket node comma default colon square bracket. We'll come outside of that. We'll open up the brackets and we'll say let open up the parentheses child dist. Set that equal to edge. Boom. Now every row in the connected component is a candidate for the minimum score, so continuously update min dist. So we'll come underneath this and we'll say min dist equals min, open up the parentheses, min dist, comma, dist. Boom. Then we're gonna mark visited as unvisited neighboring cities, or we're going to visit unvisited neighboring cities. So we're going to come underneath this and we're going to say if exclamation point visited, open up the square brackets child, then we're going to come outside of that, open up the brackets, and we're going to call our DFS function, open up the parentheses, and pass in child. But we're not done yet. We're almost there. We need to start our depth first search function from city 1, because remember, that is just a function itself. We still need to call it in the main function. So we're going to say DFS parentheses 1, and then we need to return the smallest row distance that we found by coming right here, and we could just say return min dist, y'all. And boom, that should be all she wrote. Let's give it a run. Make sure it runs properly. Oh, we got an error. Let's see. Oh, 7. Oh. Hold on, y'all. Let's see. Oh, hold on. Oh, we didn't close the parentheses over here. Now let's give that a run and see what that. Okay. Let's see. Oh, sorry, y'all. This should be a dictionary, so we still need to put the int colon. So the key is an integer. The value is an array of tuples. Let's see if that fixed it. Let's see. Okay. Let's see. Hold on, y'all. Oh, because this is not an array. This still has to be an array of tuples. Now let's give it a run. Sorry about that, y'all. It's accepted, so let's go ahead and submit it and make sure it's still accepted after we submit it. And look at that, y'all. 63 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.